Okay. Okay.
So these logs, whatever logs are getting stored in for application, are getting stored as permanent in cluster, or it will go off?
Sir, you are storing an HDFS means permanent or okay?
Means
Temporary.
permanent only, yes. Permanent. It should be permanent, yes. But sir, actually, what happened today? I restarted my machine. When I am a resource manager, when I am opening, it was not showing any application. Yesterday it was showing because yesterday I ran. So just I thought maybe.
Yeah, it will go off and come back, sir. Okay, we'll see.
No, in URL, the resource manager URL, anyhow logs will be there, but in that URL, if we will restart cluster, that application will go off from that URL, or
We'll tell you, sir. I'll explain that. Yeah. Okay, sir. Okay. Now, I'm telling you that the containers will start. Okay? Containers will start, and okay, containers will once work is completed, containers will be stopped. All those things, right? Yes or no?
yes.
Okay. I will show you practically. I'll show you practically. Is it happening or not? Okay. So. Normally, when I say clutch JPS, okay, what you will get? All the services running here, right? Yes or no? In each machine, what are the services running? Correct or not? Okay. Now we will run this one, okay, excluding this one, excluding these services. Okay. So try to understand. I'm running my clutch command only on DN. Okay, on DN machine. Okay. So before I start my job, I don't have anything here. Yes or no? Do I have anything here? Okay, it is empty. Okay, so see, I'm what I'm trying to do. I'm trying to grab anything which is not these services actually. Okay, so nothing. Now I'm submitting the I will add super. I'll add even this also. It's not also. So this is the first command, sir. Nothing is here. Now Alan is starting the command. Alan is executing the command here. This is the command he is executing. Okay. So okay, try to understand. Center. Okay. Why 186? Okay. One second. I'm submitting the job. Before submitting the job, okay, when I run this command, nothing is here. Nothing is running here. Okay. I'm checking the status in Edge node. and other 3 data nodes. I'm not checking anything in the resource manager or other nodes. Okay. So press enter. Okay. So 186 you can see Ranger has started. 185 you can see MR application master has started. Okay, 185 there are 2 AND shields. Same output. Same output. Same output. Those childs AND shields are gone. Done. Okay. So let us see what is happening here. Okay, so where we started here. Okay, so this is the place where I started. Okay, so here job is completed. Job is completed. Okay, so first, okay, I started here. When I start, before starting my job, nothing is here. Okay, when I run the clutch command next, okay, after starting the job, immediately on 186 machine, what is started? 186 machine, what has started? Ranger has started.
Ranger.
Okay, so is okay where we are talking about this. Okay, so what will happen? Okay, so whenever you submit a job, okay, in the back end, okay, Ranger has started. So Ranger has started. Okay, this Ranger has contacted a resource manager. Resource manager updated the okay, contacted resource manager. Resource manager updated that information here. The job information. This is the application edit has given. Okay, 005. Okay, after that, okay, what it has done. So it checked in the node manager, I mean cluster tester file, and understood that okay, we can launch application master here. So now tell me in which machine application master launched for this job? In which machine application master has launched? See, this is the next clutch command. Okay, so Ranger is here. Application master has launched on 185 machine. MR application master. Can you see?
Yes.
Okay, application master started. The first container starting is application master. Okay, so then okay, then what happened? After some time, if I check, okay, there are two more containers started. The name of the containers are yarn childs. What are these containers? What are these containers? Okay, so where sample1.txt file is available? Okay, previous example sample1.txt. Sample1.txt. Okay, so you take this one, this example only. Okay. So sample1.txt has 2 blocks. Okay. Sample1.txt has 2 blocks. Okay. This is block 1 and this is block 2. Okay. 48, 49. But both the blocks are in S3 and 5 machine. S3 and 5 means 185 machine. Okay. So now in this scenario, application master also started in the MR application master started here. Okay. What is the size of this application master? I didn't give any sizes. So 1 plus 2 GB. It will go with the default size of 1 2 GB. Okay. Application master has started here. After that, application master went to contacted name node and understood that there are 2 blocks for this file. Okay. So this is the first block. This is the second block. Both the blocks are available in S3 and 5. Okay. Now application master contacted resource manager and asked, hey, resource manager, okay, I want to process block 1. It is available only in this machine. Okay, give me 1 container in this machine. Okay, so in that case, okay, what RM has done, it has given 1 yarn child. Okay, this is the name of the container, which is nothing but your mapper1. Understood? Understood? Okay. Then it has given 1 more yarn child. Okay, see, you can see the difference between process IDs. This is okay, 10822, 10824. Okay, so this is the another yarn child. Okay, so this is the map2. Understood? So my application master is launched in this machine only. Okay, and my yarn child, it means okay, first mapper launched here only, second mapper launched here only. It's okay, I'm showing you the JVMs, okay, which are containers which are getting launched in the backend. Okay. So after some time, what happened? Okay. So okay, when I check after some time, okay, it is still showing okay, one mapper, sorry, one application master, two mappers, and one run jar. Okay. After some time again, okay, it is showing okay, run jar, application master, two mappers, it is showing. Okay. After that also, it is showing the same information. Okay, it means okay, these are running, these are okay in running state. Now you tell me, okay, what happened here? Okay, in this scenario, in the previous scenario, we have two runs, mappers, right? Now, do you have the mappers here in this scenario?
No, sir.
Where are the mappers then? Sir, initially,
Job done, mappers released.
okay. So initially, you don't have anything, sir. This is the first one. Okay. Initially, you don't have anything. Job related, no job related containers, JVMs otherwise. Okay. When you submit your job, okay, the first thing it has started is Ranger on Edge node. Okay. Ranger contacted resource manager. Resource manager launched application master. Where application master is launched now? 185 machine. Okay. 185 machine. Okay. After that, what happened? Okay. Application master contacted name node and understood that two blocks are available in this 185 machine. So application master requested okay, resource manager, give me two resources. Okay. So now RM requested node manager to launch two resources and assign it to application master. Okay. Now these two resources are launched here and these are assigned to application master. Okay. So now application master will process first block in the first container, second block in the second container. Okay. Slowly these two containers started doing their work. Okay. So here also they are still doing their work. Okay. Okay. In this still they are doing their work. Okay. Here also they are doing their work. Okay. But when it comes to here, okay, okay, see here, this is released. This is not there now. It means okay, mapper one work is completed, mapper one is released. Okay. And even okay, mapper two work also completed. Okay, that is the reason it is showing process information unavailable. It means okay, it is at the end of closing actually. Okay, so 10822 also closed, 10824 also closed. Both are closed. Okay. After that, if you see, but okay, at this moment, okay, both mappers are closed, but still application master is there.
Yes, sir.
Sir, Ranjar is still there.
Yes, sir.
Okay, it means okay. So both mappers are completed. They stored their output into the local file system. Mapper one output, mapper two output. Okay, and okay, these two are both the mappers are released. But now only two are available as MR application master and Ranger. These two are available now. Correct or not? Okay, that is what you are seeing now. Okay, after that, okay, can you see this one? Okay, one more handshell in which machine? In which machine?
183.
183. What is this yarn shell again? This is the reducer. 183 means this machine. Okay. So this is the place where reducer 1 has started. Okay. With 1 core plus 1 GB RAM. 1 GB RAM. Understood? Understood, sir. This is the place. Okay. It means okay. See, after releasing both the mappers only, reducer launched. Correct? Okay. If you don't reply me, I'll continue. Nothing can be done. Okay. So now, okay, at this stage, okay, we have application master, we have reducer, and okay, we have Ranger and edge node. Okay. After that, if you see, okay, so after that, reducer work is completed. Okay. Once reducer work is completed, okay, immediately, what MR application master is doing? Okay, MR application master is confirming Ranger, saying that okay, hey Ranger, so reducer also completed, your work is completed. Okay. So you also bye bye. Okay, so it means like Ranger also at this moment, okay, no Ranger. Ranger is not there. Okay, but only MR application master is there. But now what MR application master is doing at this stage? It has to delete a few things, right? Okay, there is a partial output here, right? It is deleting that partial output. Okay, so after that also it is still doing the partial output deletion. Okay, now at the end, okay, even MR application master is released. Now we came to the starting point. See here, okay, in these, okay, 10 20 seconds, okay, how many things happened? Okay, Ranger started, okay, MR application master started, then okay, mapper started, then mappers released, then reducer started, reducer released, then Ranja released, then MR application released. Finally, everything is entire job is closed. Understood, guys? Are any questions? Understood? Are any questions? Okay, fine. Okay. So, and I told you that okay, every time a container is launching, every time a container is launching, okay. Every time a container is launching, okay, it will update this table, right? This is what I told. It will update this table. Okay. We will see that also. We will see that also once again. I'm deleting this output directory again. Okay. So now what I will do, I'll go to resource manager page. Notes. Okay. Okay. This is the page. Now, if you see all are running, so okay, again user course and user RAM. Anything is there? All are empty, right?
Yes.
Before I start my job, okay, everything is empty. Before I start my job, everything is empty. Cores are okay. All 16 GB available, 16 cores are available from each machine. These are the available resources. Okay. Now what I will do, I will take a new Word document. Okay. Before I start my work, okay, this is the status. Before I submit my job. Print screen. Okay, this is the status of my job. Okay. Now what I will do, I will submit my job. When I'm submitting the job, press enter. Okay. F5, print screen. 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 Okay, F5, print screen. Okay, F5, print screen. Super. Okay, let us see what are the screenshots I've taken. Okay, before I start my job, everything was okay. So do you have anything in the container column? 0, 0, 0. 0 bytes used, 0 bytes used, 0 bytes used, 0 cores used, 0 cores used, 0 cores. It means my entire cluster is free. Yes or no?
Yes.
Okay. So now you started the job. Okay. Now you have, okay, what is this? Okay, you have one container launched on S3 and 4. Correct?
Yes.
Okay. So what is this one container? And okay, you see this container, how much, okay, out of this total memory 16 GB, 16 cores, how much it is using?
2 GB.
2 GB.
2 GB and 1 core. 2 GB and 1 core. Okay. So 2 GB, 1 core. Who will use normally 2 GB, 1 core?
Application master.
Application master.
Okay. So can I blindly say that, okay, on this machine, okay, application master is launched S3 and 4?
Yes.
So I'll go to the same one. Okay. Here in the next scenario, where application master started, 3 and 4. Application master started here. Okay. Guys, okay. In the last time when I run the same job, application master started in a different machine, or not? Huh?
Yes.
Yes, sir.
So is there a rule that okay, every time okay, my mappers or reducers or my application masters will be launched on the same machine? If you run the same job, okay, multiple times, okay. See, it's purely depend on resource availability. Okay. So who is replying fast? Understand? Okay. So this time, okay, MR application master lines. Okay, here can it used 1 core 2 GB. Okay. So after using 1 core 2 GB, what is the left out resources here in this machine? What is the left out resources here?
14 GB.
14 GB and 15 cores. Is it
15
immediately
cores.
getting updated or not? It is immediately getting updated in the table or not?
Yes.
Yes,
Yes,
sir.
it is getting updated. Okay. After that, okay, what happened? See here. Okay. Now you can see one container here, one container here. Okay. So two containers. Of size what? 1 GB, 1 core. 1 GB, 1 core. Correct? So can I say this is mapper 1? This is mapper 2?
Yes.
Huh?
Yes, sir.
Yes, sir.
So
Yes, sir.
mapper 1 has launched here. This is the mapper 1. Map 1, okay, has launched here. Size of map 1 is 1 core plus 1 GB. Okay. Where mapper 2 launched here in this picture? Maybe M5, S3N3 and S3N5. Okay, this is the place mapper launched. Okay, this is the second mapper which got launched here. Okay, so mapper 1 is processing block 1 and okay, mapper 2 is processing block 2. Yes or no, sir?
Yes.
Mapper 1 is processing block 1, mapper 2 is processing block 2. Okay, so now what next? Okay. The next picture also same number of mappers are available. In the next picture also same number of mappers are available. It means okay, in this stage, okay, we have application master, 2 mappers running here. Okay. In this stage also application master, 2 mappers are running here. Okay. Application master, 2 mappers. Application master and okay, 0 containers. What happened, guys? Here?
Mappers work
Mappers
is
are
done.
completed. Mappers are completed. Okay. So when mapper is completed, okay, what is the available memory now?
16
See,
GB.
when mapper is running, what is the available memory in available cores?
15 GB.
15 GB, 15 cores. Correct? Okay.
Yes.
But when mapper is released, what are the available resources?
Again
16
16.
GB,
Again, 16 GB,
16
16 cores. Okay. So now mappers are released. Now mapper 1 is released, mapper 2 also released. Both are released. Okay. But my still application is still there. Okay. So now, okay. So here, can you see this one, guys? Here. Okay. Now there are 2 containers here. 2 container. So earlier there was 1 container, right? Container. Okay. So which was application master. Okay. Now I have 1 more container. What does it mean? It can be a reducer.
It's reduced.
Reducer.
Reducer. Okay. So now this is the reducer. Okay. Now what is the default size of reducer? 1 to 1 GB. Okay. Now after launching, okay, when both are running in this machine, okay, what are the user resources? 2 cores, or not? 2 cores and 3 GB RAM. Sir, no?
Yes.
Okay. Now what is the available memory now?
14
Available memory 13 GB, 14.
14.
Clear? See here, guys, okay. See, it is just okay. It's just a use and throw. Okay. Whenever you want, okay. Okay. See now, okay. From each machine, these are the resources available. 16 GB, 16 cores. 16 GB, 16 cores. 16 GB, 16 cores. These are the resources available. Okay. So now for your program, what is required? You take it. Okay. Run your program. Once your program is done, release it. Understand? So this is what is happening, right?
Yes, sir.
So you are taking it, okay, whenever, okay, you see, you want application master, okay, you are taking 2 GB, 1 core, you are taking here. And once your work is done, you are releasing it back to pool. Correct? Again, okay, again, if somebody submit a job, okay, maybe the same core, same RAM will be used for that job. And once his job is completed, it will release back to pool. Again, okay, third, okay, one more person will come and submit the job. So the resources will be used for that job, okay, and given back to pool. So here, the same course, so same RAM is helping to run multiple jobs here. Yes or no? Yes or no, guys?
Yes, sir.
Yeah.
Yes, sir.
Okay.
Yes.
So here, so it means it is clearly saying that okay, there are two containers are running here. One mapper, one reducer. Sorry, one reducer and a application master. These are used. Now here, guys, okay. So now what is happened in this picture? Now only one container is running. Okay, that is 2 GB, 1 core. So other container is released. It means
Reducer.
is released.
User work is completed.
Okay, reducer work is completed. Okay, reducer is released. Okay, now we have only application master. Okay. In the next slide, okay, even application master also released. Okay. Yes or no?
Yes.
Yes, sir.
Okay.
Yes, sir.
So this is how. Okay, this is how the resources will be allocated and released, allocated and released, allocated and released. Okay. So now, okay, you ask me a question, sir. Okay, what in case? Okay, so now if one person is running the job, okay, so we'll see the different scenarios here. Okay, now one person is running the job. Okay, he need more than available resources. See here, okay, I have 16 core, 16 GB, 16 core, 16 core, 16 GB. Okay, but he need more than this one. Then what will happen?
Fail, it will fail, job will fail.
You need more than this. No. See here, okay, now okay, I have. So try to understand, sir. I have 3. Okay, NM1. Okay, so here 16 GB RAM plus 16 cores we have. Okay, 16 cores. Okay, NM2. Okay, this is also same. NM3. This is also same. Yes or no? The resources are same, right? In all the 3 machines. Now, if somebody coming and asking, okay, coming and asking is somebody is running a job. So job 1, okay, running on 20 GB data. So now 20 GB data means how many blocks you will have? Try to understand this. Okay? Job 1, okay, running on 20 GB data. Okay, so how many blocks you will have when I say 20 GB?
1 block.
1 GB means okay, 8 blocks. 20 GB means okay, 8 into 8, 64 blocks I want. I have 64 128 MB blocks I have. Okay. That means okay, how many blocks I have now? How many blocks I have, sir? 64 blocks I have. 20 GB means
64.
sorry. No. 160 blocks, sir.
160.
GB 8 blocks. 20 GB means 20 into 8, 160 blocks. Okay. It means okay, now in this scenario, how many mapper JVMs I want? Okay, suppose okay, map JVM size, map size equal to 1 core plus 1 GB RAM. Okay, 1 GB plus 1 core. Okay. Now tell me, how many mappers are required in this scenario?
160.
Huh? Number of mappers.
160.
160 mappers. Okay. Now 160 mappers. Okay. 160 mappers. Okay. Now tell me, can I launch all 160 at a time? So
No,
now,
sir.
okay. Now what? Okay. Application master will do. Application master, okay, I want to launch 160 mappers. Can you help me? Okay. But with this capacity, first of all, okay, can I launch this size of mapper in these machines? Can I launch 1 core 1 GB here?
Yes.
Huh?
Yes, sir.
Yes, right? Yes. Okay. 1 core 1 GB can be launched. Okay. So now, okay, if you ask, okay, 160 mappers, okay, it means okay. So as per these resources, it can give only. So first application master will start. Okay. Application master will be there, right? For application masters. Application master. So it will take okay 2 GB plus 1 core. Okay. Okay, after taking this one, this is mandatory, right? Application master is mandatory. Okay. After this one, okay, available free resources. Okay. How many? Okay, let's say application master launched in any one machine. Okay, so it means okay, in that machine, okay, 14 GB, 15. Okay, so it means 15 plus. Okay, think that it is launched here. So here, okay, so 16. Okay, 2 GB 1 core is used, right? 2 GB plus 1 core is used here. Okay, that means okay, I have resources like okay, 15 GB plus 15 cores. Okay. But here it is different. It is full resources are available. Okay. Now, after launching application master, what are the total resources available here? What are the total resources? Okay. 32 plus okay, 32 plus 36 plus 46. 46 GB RAM plus okay, 47 GB, 47 cores. This is available. After
Yes,
launching
sir.
application masters, okay, available resources are these one. Now with this much GB RAM and these many cores, how many mappers I can launch at a time? But how many mappers? No, how many
46
mappers?
mappers.
How many mappers I can launch? I am supposed to launch
160.
160 mappers. Okay, but okay, what are the available resources here?
46
GB, 46 cores. What is the size of one mapper here? 1 GB 1 core. Okay, if 1 GB 1 core is my size of one mapper, how many with these resources? How many mappers I can launch?
46. 46.
46 mappers you can launch. Okay, so iteration 1, okay, round 1. How many mappers? 46 mappers. Okay, once the round 1 is completed, okay, it means okay, 46 are used and released. Yes or no? Again, okay, so after completion of round 1, okay, we will have same resources, correct? In round 2, again 46. Okay, so 46, how much it has come? Okay,
92.
92. Okay, so round 3, okay, more 46. It means 46 into 138 has been done. Okay, so now how many more required in round 4? 160 minus 138. Okay, means okay, 22. Okay, round 4, okay, 22 mappers will run. Understood, sir? What is happening? See, I have less resources but more mappers to run. In this scenario, it will go by round in the form in rounds. Okay, so then after completion of round 4, then okay, so round 5 for reducer on reducer. Now one reducer or two reducers or multiple reducers, okay, it's purely okay, that okay in this scenario. Okay, so reducer size okay 1 core plus 1 GB. It means okay, so now I can launch one reducer. Any reducer cycle launch. Okay, now maybe in round 5 one reducer will run. Now job is closed. Yes or no? Is it fine? If you submit the job on 20 GB data, it will go like this. It will be complete in 5 rounds. Understood? Understood
Yes,
or not?
Yes, sir.
Okay. So now let us go this scenario, sir. Okay. I'll go with different scenario. Now I'm submitting job to. Okay. Now I'm saying that okay, my mapper size is okay. And okay, so again, okay, so we need to understand that max container, min container sizes. Okay. So here, okay. So min container, max container. Okay. Min container is okay 1 GB plus 1 core. Okay. Max container I'm giving like 4 GB plus 2 cores. Okay. These are the rules, guys. These are the rules. Okay. As per these rules, okay. Now, okay, I'm running job 2 on same okay 160 GB data. Okay, sorry, 20 GB data. Now I'm giving mapper size as okay. Now I'm giving the mapper size as 1 GB plus 3 cores. Can I give like this 1 GB 3 cores? Can I give mapper sizes 1 GB 3 cores?
No, we cannot,
No, sir.
Why?
because we mentioned the
Maximum
max.
is 2 course, sir.
Maximum only 2 cores. Okay, you cannot go beyond this one. Okay, so it means okay. So see, your one RAM is okay in the limits, but okay, cores are in the limit. So here okay, you are clearly telling that okay, for any container, minimum RAM is 1 GB, maximum RAM is 4 GB. Okay, minimum cores 1 core, maximum cores 2 cores. Okay, but here okay, you are giving beyond the allocation, beyond the min and max sizes. Okay, in this scenario, your job will fail. Directly saying that okay, no, I cannot run. Okay, but can I give okay 1 core okay, RK? Can I give 5 GB plus okay 2 cores? Will mapper run?
No.
No, sir.
No. Okay, mapper will not run because okay, again, okay, so this 5 GB is not in the limit of 124 GB. Correct. Correct or not?
Yes,
Yes,
sir.
sir.
Correct.
Okay, so this is the another problem. Okay, so that is the reason. Okay, so developers should be knowing, okay, when they are submitting the job, okay, what is the max size, what is the min size I can give for any container. Okay, they should be knowing. So we need to tell them that, hey guys, this is the limits for you. Okay, you cannot go beyond these limits. Suppose now, okay, now when I go like this, okay, 6 GB 2 cores, 4 GB 2 cores.
Yes, sir.
Huh?
Yes, sir.
Can go, right?
Yes.
Huh? Now tell me, okay, how many rounds it will go? In round 1, okay, how many it will execute? So if my mapper size is this much, in round 1, how many I can execute? How many mappers I can launch? So what are the
4.
how 4, sir? So what are the free resources, sir, here? Total resources from all these 3 machines? 46
46.
GB 47 cores. Okay. Now,
11.
okay, we'll see 11. Okay, so if I launch 11 cores, 11 mappers at a time, how much they will use? 11 into 4 GB, 44 GB. Yes, available. Okay, 11 into 22 cores. Yes, available. Correct or not? After launching 11 mappers, okay, no RAM to launch one more mapper. Okay, it means okay, in the first iteration it will go for 11 mappers. Okay, the second iteration also will go for 11 mappers. Third iteration it will go for 11 mappers. Okay. So like this, okay, every iteration it will go for 11 mappers. Okay, so how many 11 mappers means okay, 160 divided by 11. 160 by 11. It means 14 rounds it will go. Okay. So 14 into 11. Okay, 154. Okay. In the last round, 15th round
Sorry,
it will go.
that's number of mappers, right? Okay, I got confused. Got it. Thanks.
Okay. So in the 15th round it will go with 6 mappers. Okay. 16th round it will launch reducer. Understood, sir? See, the same data, if you go with okay, 1 core 1 mapper, it is completing in 5 rounds. The same data, okay, if you go with 4 GB, 2 cores, it is completing in 16 rounds. But job is getting completed. Yes or no? Yes or no, guys?
Yes.
Even though it is taking more rounds, but your job is getting completed or not?
Yes, sir.
Yes, sir.
Yes, that's the beauty of okay, Hadoop, sir. Okay. Hey, in the traditional processing, if I want to execute a job on 20 GB data, you need 22 GB, 23 GB JVM, or minimum 24 GB JVM. But are you going with 24 GB JVMs? Can you launch in any machine? Okay, you have 24 GB RAM. If I go traditional way, I cannot run okay my job in a single JVM in any machine. But if we go in a distributed way, so the same 20 GB data is getting processed in small JVMs, small and multiple JVMs. But end of the day, you are getting your output. Yes or no?
Yes, sir.
Yes, sir.
Okay, so that's how it works, guys. That's how it works. Okay, so what we will do? Okay, so we will come back to the theory part. Okay, so from 3 days, okay, we didn't test the theory part. We are just looking concentrating on the practical part itself. Okay, so now, okay, you know what is resource manager? Okay, then what is application master? Application is one application master for each job or application. Okay, one application master. Okay, so for any job you will have only one application master. Okay, it is kind of a ladder container in the application. So application master is the kind of a ladder, so which takes care of which is responsible for end-to-end job execution. Okay, so responsible for analyzing the application requirements and creating the job configuration XML. Okay, understand? So it is the responsible person to make sure the job is successfully completed till the end. Okay, and okay, it means okay, it is responsible for negotiating the containers with RM and allocating the task in the container. Okay. So what do you mean? So getting the containers, okay, and okay, releasing the containers, okay, creating the containers, releasing the containers, okay, okay, requesting for new containers, okay, requesting to create new containers, requesting to delete existing containers, okay. The responsibility of our application master is requesting to create new containers, requesting to delete old containers or completed containers. Okay, this is the work of application master. Okay, so monitor the progress of the task and tracks the status of the application in the job history JSON file. Okay, so here, okay, now we understood that. Okay, we understood that application master will write, okay, few files, guys. Okay, what are the different things application master will write? Application master will write, okay, we will create, okay, one file which is called as job configuration XML. Okay, for any job, okay, you will have, okay, if you see the history, you will have configuration XML, job configuration XML. Yes or no? Who will create job configuration XML, guys?
Application master.
Application master will create. Okay, okay, so where it will store this configuration XML file? On HDFS. Understand? On HDFS. Okay, yesterday I've shown you the path also. Okay, where it will be stored. Right. Do you know where it will be stored? This is the path. This is the location where you can see. This is the path. This path cannot be accessed by all people. So you need to check this user. Okay, HDFS, DFS, FNLS. Okay, so I will do one thing. Okay. Okay. Now you see. Okay, so we have only config symbols. Okay, can you see? I'm wrapping only config symbols. What are, see now today how many jobs I executed, guys? Okay, from start of the class, okay, how many jobs I executed? Total 3 jobs I executed. Yes or no?
Yes, sir.
If you see the resource manager, okay, how many jobs I executed today? Sunday. Okay, this is till, okay, this is okay, yesterday, Saturday, March 26th. Okay, Sunday, March 27, Sunday, March 27, Sunday, March 27. Okay, so Alan submitted word count. Okay, so this is the 3 jobs I submitted today. Yes or no? 3 jobs I submitted today. So for each job, you have a configuration XML or not?
Yes, sir.
Sir,
Yes, sir.
one question. So one question here.
Ah.
Sir, this word count job, we can run in in real servers, we can run it for testing purpose, or
For testing purpose, sir. Yes.
we can run it for checking whether everything is fine or not, like that.
Of course, yes.
Okay. Sir.
Yeah. Okay. So now I executed three what to say jobs today. So now for each job, okay, there is a configuration XML. Correct or not? Okay. Now if I want to know, if somebody come and ask me, okay, so I want to see what are the configurations I used in job 4. Okay, job 004. Okay, so job ID 0_004. Okay, I can tell you what is the configuration they used. And okay, what is this location? Is it STFS location or local file system location? Is it STFS command?
Yes.
STFS location. Okay, and okay, what is the replication factor for this file?
3.
3, sir. 3.
Okay, so now.
And it's on history server, right, sir?
No. Don't use the different words here. Okay? Very thin line to make you understand. Okay. So here, application master is the one who is creating the job configuration XML and storing into STFS with replication factor 3 by default. Okay. Are you clear? And what you will have in the job configuration XML? What you will have in the job configuration XML? Tell me. So what are the all properties you used? Okay. See, when I say job execution, to execute a job, you require more and more lot of properties. Okay. But okay, your job you may provide or you may not provide all the properties. So if you see any job, okay, how many properties we have? You take, okay, this job, click on history, configuration. How many properties we have here, guys? 1484 properties. Okay. For each job, okay, you will have this 1484 properties for each job. Understand? And okay, there may be some more properties also. If you pass anything in the command line, okay, there may be some more properties also. But these are the minimum properties. Okay. So these properties, few properties may come from the site XMLs. Few properties may come from the environment configuration files. Okay, so few properties may come from the job history, job configuration class. Okay, or few properties may come from the command line. Okay, but end of the day, whether okay the property is coming from command line or XML file or some other file, end of the day everything will be considered in this one. Okay, so here this file is getting created by application master and storing into STFS with replication factor 3. Till this you are clear? Till this you are clear, guys. Okay. Now, okay.
Sir, but see, we see configuration file only for today. What happened to the files which were there yesterday?
Okay. Okay. So now it is 3. Okay. Now what is the date here? Can you see this one?
27th.
Okay. Now this is for 27. Okay. So now if you want to see what other jobs you executed for 26th, okay. So now you see here for 26th you executed these 3 jobs. So 26th date, okay, you have these three configuration files.
Got it. Yeah. All are there actually. Yeah, sure.
Yes, all are there. Okay, but in different directories. Understood? This is year, month, date. Understand? Okay.
Maximum size we discussed just now. So that maximum size configuration, where it took it from, that container maximum size.
Container
We were
maximum
discussing
size
here.
and all, okay, in the on-site XML, right?
Okay, sir. Yeah, yes. Got
On-site
it.
XML. Okay. Next. Okay. So now, okay, this is file. Okay, this is fine. Okay, so this will talk about okay all the properties which we used in the job execution. Correct? Correct or not? Okay. But here, okay, when I click on okay map task, okay, this is telling that okay how many map tasks I executed here. Okay, what time map? What is the current status of map task? Okay, and what is the status of map task? What time it started? What time it ended? Okay, how much time it has taken? Okay, so what is this, guys? Actually, what is this?
Mappers.
Huh? This is the history, guys. See, normally, okay, see what I can say. So there is a question, sir, if job fails, how to troubleshoot? Okay, that will come in the next session, madam. Okay, so I'll cover that, but that is very, very important. Okay, so as of now, okay, I'm making you understand okay how the job execution will happen. Okay, so now the question here is that okay, so here okay, what is this, guys? Okay, what time mapper has started? What time reducer has started? What time okay? How much time it has taken? Okay, so whether it is succeeded or not? Okay, in which mission it started? Okay, understood? Okay, so what is this actually? What is this? Tell me. Huh? Can I say this is running history of a job? Sir, what is the difference between, okay, I will take a cricket match, sir. I'll take a cricket match, okay? So team one, okay? Team two, okay? So here, okay, you will say player one, okay? Player one, player 11, okay? Yes or no? These are the two teams, okay? So they are playing cricket match, okay? So this will be decided at the starting of the, this will be decided at the starting of the match itself, correct or not? Yes or no, guys?
Yes, sir.
Okay, so now, so these are the, okay, so this one you can take it like, okay, so this data is available in the config XML, job config XML, okay, but now, okay, so here ball 1, okay, ball 0.1, first ball, okay, so played by player 1, okay, bowling, okay, So team 2, okay, we player, okay, maybe. Okay, so team 2 player 2, player, okay, 10. Okay. So batting, okay. So team 1, player 1, okay. So 4. Yes or no? So again, okay, for ball 2, okay, again, okay, so 6, ball 3, okay, out. Okay. What is this, sir? What is this? Okay, player 1 played from, okay, player 1 played from, okay, so first over to, okay, first over to 25th over. Okay, and okay, he played 25th over. Okay, okay, he played, okay, 90 balls. Okay, so 100 runs. Okay, so what is this actually? What is the difference between this data and this data? What is the difference between this data and this data? So this is a data which will be decided at the starting of the match itself. Yes or no?
Yes.
This is the data which will be decided at the starting of the match itself. Okay, but this data will ball 1. What is ball 1? Okay, who will play ball? Who will bowl ball 1? Okay, who will bat ball 1? And what is the score? So will it be decided at the starting of the match itself?
No.
No, right? Okay, so it means, okay, this is, okay, can I say this is running commentary?
Yes, sir.
Sir.
Of match. Okay. Now, if I see what is the use of this running commentary, guys? What is the use of this running commentary? I can easily say that, okay, by looking at the running commentary, I can say how many overs are completed. Okay, okay, how many fours, how many sixes, okay, and okay, how many people are out. Yes or no? Everything I can see here.
Yes.
Correct or not? Okay. So now, okay, you bring the same thing to mapper side actually. So this is the cricket side. Okay, you come to technology side now. Okay. So now, okay, so application master started in 3 and 5. Okay, started time. Okay, this time started. Okay, ended at this time. Okay, so okay, 8:50 ended at this time. Okay, so then okay, mapper 1. Okay, started in S3 and 5. Okay, this is the time. Okay, this is the start time. Okay, this is the start time. Okay, this is okay, this is the end time. Okay, so status is succeeded. No. Then okay, so mapper 2. Okay, S3 and 4. Okay, started this time. Okay, so now mapper 100. Okay, S3 and N3. Okay, so started at this time. Okay, ended at this time. Okay. So now, can I say this is also running commentary? Huh? By looking at this running commentary of the job, okay, can I easily say that, okay, where application master is launched, where mapper 1 is launched, what is the status of mapper 1, okay, or how many mappers completed so far, okay, yes or no? So this will start at the, this will start along with, okay, as soon as, okay, you start your application master, okay, and okay, when this will be ended, when this commentary will be ended, when the commentary will end, when you reach, okay, ball of, okay, 49 point, okay, 49 point or 49.6, it means, okay, this is the last ball. Till last ball, you will have the running commentary. Okay. Here also, this running commentary for the job will go till last reducer. Okay. So reducer 1 here, okay, let's say reducer 1. Okay. Okay, let's say I'm using 10 reducer. This is the last reducer. Okay. It means, okay, this commentary also will stop at the last reducer. Okay. Now, by looking at this file, can I say that, okay, what time is application master started? Where it is started? How much time it ran? Okay. What is the status of the application master? Okay. What is the status of mapper 1? What is the status of mapper 2? What is the status of mapper 100? All those things can I tell by looking at this file? Huh?
Yes.
Yes,
So
sir.
running commentary of a job. okay, is called as job history JSON. Job history file. Okay. So this is another file, okay, which will be maintained by, so here application master only will have the full clarity of, okay, each and every mapper reducer task. Actually, that is the reason. So here jhist.json file. Again, this is also created by application master and stored in HDFS with replication factor 3. Understood? Okay. Now, by looking at this one, I will understand the player list. By looking at this one, I will understand the running commentary of the match. What is the status of the match at any point of time? Yes or no? So here also, okay. So if it is job, okay, I will understand. Okay, what are the properties we used in the job job execution, and okay, by looking at this one job history JSON file, okay, you can understand what time mapper started, okay, what time reducer started, what time, okay, job is closed, okay, everything, job is completed, what is the total time taken to complete this job, complete information about your job. Understood? See, these two files are very, very important, guys. So where I can see these two files, okay, you can see these two files here itself, okay. So this is the conf XMLs for each job. In the same way, you have JSON. JSON files. Okay, can you see something called JSON? What is the JSON? So this is the job 004. Okay. So for each job you will have, okay. So job 004 JHIST, job 005 JHIST, job 006 JHIST. Okay. Understand, guys? See now, okay. This is the UI, resource manager UI. Okay. So here you are seeing, okay, all the jobs here 06. Okay. When I click on this one, it is telling that, okay, so username is Alan. Okay, submit. Okay, who submitted? Alan submitted. Okay, name, word count. Okay, application type, map reduce. Okay, what time it is started, what time it is launched, what time it finished, total time taken here. Okay, status. Okay, succeeded or not. Okay, see, it is showing so much of lot of information here. Okay, from where this information is coming today? Username, okay, username, okay, the job name, okay, job type, okay, maybe these are coming from XML file. But what time it is started, what time it is ended, okay, how much time it has taken, what is the status, all these things are coming from. So it means, okay, whatever information you are seeing here, whatever information you are seeing here, okay, whatever history you are seeing here, whatever the history you are seeing here, everything is coming from either of XML or job history JSON. Okay, so whether job is failed or successful, these two files will be available. Understood?
Okay, sir.
A job conf.xml file will maintain all the jobs information.
Sorry?
Job conf.xml file maintain the all jobs information, right?
So job configuration XML will contain the properties which you used in the text in the job. Conf XMLs. Okay. Let me write once again here.
Sir, where we get this path, sir? Where we get this path information, sir?
1 second, sir. 1 second. Conf XML. Okay. Job history. Okay. Job.jhist. Conf XML will contain, okay, properties used in the job execution. Okay. Running history of the same thing. Okay. If you correlate with get, okay. Okay. Players. For part of the match.
Got it, sir. Super.
Both are different, right?
Yes, sir, both are different. That is the starting of the
What will be
job.
decided at the starting itself. Okay.
Yeah.
It means, okay, as soon as job is started, okay, the responsibility of application master is to create this file. Okay. This will be created at the starting.
Yes.
Okay. This will be created at the starting, but continuously getting updated. Okay. closed at the ending. Yes or no?
Yes.
Okay. Okay. So start. Okay. Created at the starting of the job. Right. Okay. So created at the starting of the job. Closed at the
End of the file. End of the job.
Created and closed. Once this is completed, okay. Once this is completed, okay. Once this is written, okay, it will not. You cannot change anything. But okay, this will be updated. Okay. So now, okay, guys. Okay, you remember? Okay, one point here. You remember? Okay. I've shown you here somewhere here. Okay, no, here only. Okay. See here. If you see the situation, okay, this is the application master, Yan child. This is the reducer. Ranger is still there. Okay. After completion of the reducer, okay, Ranger is in the next step. Ranger is there in the next step.
No, sir.
No, sir.
But application master is there. Okay. See, the person who submitted job is also released. So Ranger is the one, right? Who started the first JVM.
Yes, yes.
That is also closed. Okay. That is also closed. Mappers also closed. Reducers also closed. But okay, what MR application master is doing at this time? Huh? What an MR application master is doing this time? Okay. Until okay, so till end of each reducer. Okay. This commentary information will be stored inside its own JVM. Inside its own JVM. Okay. At the end, what it will do? It will write the data into. It will write the commentary, final comment. Full commentary into STFS. Till that time, okay, where it will keep. So MR application master will keep the entire running this one. Okay. Right. What I can say. Otherwise, okay. So don't create confusion. Okay. MR application master will be updating the running commentary of a job. Okay, from starting to ending. From starting to ending. Clear? Clear, guys. Okay. And okay, this is the file config XML file. This is the job.json file. These are the two files which will be created by application master. Okay. Any questions?
Sir, from where we will get the path of these files, sir?
Sir, okay, here itself you can see, right? Click on configuration, you will see the path.
Okay, this is for configuration. So what about history, JHist, sir?
In the same location.
Okay, in the same location
Yes,
with
sir.
JHist.
With
Okay.
the .js extension.
Okay, sir. Thank you, sir.
Yeah.
Sir, you have shown almost 1400 configuration files, right, sir, in Resource Manager.
Yes, sir.
So by default, it will come, sir, by installing Hadoop.
Of course, yes. Yes.
So in every node, like you will find these many configuration files.
Sir, okay,
Like-
see, when I install Hadoop, okay, what configuration files came? So user local Hadoop, okay, they say Hadoop. Okay. These are the configuration XMLs which are created automatically. Understand?
Okay.
Which are created automatically. Okay. But okay, so out of this one, what is changed here? Okay, now capacity scheduler. Okay, it is showing July 7th, 2020. Okay. But what is changed here? Okay, so let me show you. Okay. So here there are total, okay, how many are there? 37 XML files are there. Okay. Now out of this one, okay, now you see how many files okay we modified. So these are the files okay, modified on March 10th, 16th, 19th, 24th. Okay. See, day before yesterday I started Yarn. That is the reason. Okay, day before yesterday I made the changes to Yarn. Okay. Only these are the XML files modified by us. Okay. The remaining XML files, whatever you see, July 7 and all. Okay. 2020. So these are all okay. These files I did not touch at all. Understood, sir?
Right, sir, right.
Okay. So, but okay, see, all these files, all empty files created okay, when you install your Hadoop. Okay, but later we modified these files as per our requirement, and okay, we pushed these files to all other nodes also.
So that means in how many times you are modified, that many times in store in that resource manager configuration files. Suppose if you modified n number of times.
So every time you modify, okay, you need to restart the resource manager.
Okay.
Got it?
Yes, sir. Clear.
Okay. Okay, guys. Okay. So now, okay, so responsible for negotiating the containers. Okay, this you know, and okay, monitor the progress of the task and track the status of the application in a job history JSON file. It means okay. So how many containers are there? So what is the current status? Okay, when it is started, when it is ended. Okay, all this information will be stored in the job history file. So it is responsible for end-to-end execution of any job or application. Understood? So end of the day, application master is the responsible person to complete the job end to end, from starting to ending. Okay. Now, what is node manager? Node manager is the slave service in the YAML framework. Okay, and runs on each data node. Okay, and it provides information to RM through heartbeat and total allocated and available resources. Okay, so each node manager will send a report to resource manager saying that okay, I have this many cores with me and this much RAM with me. Okay, these many cores are used, this many are free. Okay, so this much RAM is used, this much RAM is free. This complete information will be given to resource manager, and resource manager will maintain that okay, if you see the resource manager UI, resource manager will maintain that information in this page, in the UI. Okay, so this is the table. So this table is called as cluster state store. Understood? Cluster state store. This is cluster state store. Okay, and this table is called as application state store. So cluster state store will have information about okay, cluster nodes. Application state store will have information about the submitted applications. Understood? Understood? Or any questions?
Yes, sir.
Okay. Now, okay. So it provides the okay. So then it takes care of launching, releasing, execution of containers. So what NM will do? When RM say okay, create a container, it will create. When RM say release a container, it will release. Okay. Run a container, it will run a container. Okay, so that's what the work will be done by this one. Okay, kills runaway containers at times. Okay, so in between some containers will be killed automatically. Okay, so some containers okay, will be still running okay for a long time. And if there are any issues with those containers, it will kill those containers. Okay, I will explain the failure scenarios in the later stages. Clear? Clear? Are any questions? Okay. So now when I say MapReduce program model, it is the programming model which is independent of programming language or platform. Okay, so since the programming model is designed in Java, so it can run on any language. I mean, you can write your programs in any language or you can run it on any platform. Okay, and normally MapReduce program will have two phases. One is map phase, and other one is reduce phase. Okay, when I say map phase, usually it is called as a segregation phase, and when it's a reduce phase, usually it is called as a consolidation phase. Understand? Understand this? Okay. So you know what is segregation and what is consolidation now. Okay, and this is how it works actually. Okay, so now one point okay, I missed here, guys. Okay, so all these days okay, I was telling that if I have 10 mappers, okay, 10 blocks, 10 mappers, right? This is what I was telling, right? All these days.
Yes, sir.
Okay, now take this scenario, guys. Take this scenario. Sir, I have sample1.txt. Okay, sample1.txt. Okay, think that okay, my replication equal to 1 only. Which is in DN1. It's in DN2. It's in DN3. Okay. These are the 3 blocks I have. 1827, 2829. Okay, 28 is here, 29 is here. These are the 3 data nodes. Okay. Now, okay, think like this, guys. Okay, think like this. Okay, think like this. Okay, my data is like this. Okay. So now, if you see my sample2.txt, this is the content of my sample2.txt. Okay. Hadoop is good. Hadoop is bad. Hadoop is super. Okay. So this is the content. Okay. Now, when I put this file into HDFS in the blocks, okay, it is coming like this. So this is here. Okay, what is happening here? Hadoop is good. Okay, but okay, HAD it got cut here. What does it mean? Huh? What does it mean, guys?
That block is
Tell
out
me.
of space.
This is 128 MB. Okay. Okay, so take this one. This is the file. Okay. Total file 250 MB. Okay. Okay, let's say 128 MB. 128 MB. Let's say this is 256 MB. Okay. 256 MB. Let's okay. 44 MB. Think like this. So the total size of the file is 300 MB. Okay, 300 MB. Okay. Now tell me. Okay. Now I want to count. How many times Hadoop word is repeated? This is my requirement. Okay. How many times my Hadoop word is repeated here? Okay. What I will do now? So I will run my job. Okay. Application master is launched here. Let's say application master is launched here. Application master contractor name node told okay 3 blocks are there. So now application master is asking resource manager give me 1 container here. So it means okay it has given mapper 1. Okay. Give me 1 more container here, mapper 2. 1 more container here, okay, mapper 3. Okay. So now, okay, so all the 3 mappers are launched here. Okay. So for mapper, what is the input here? Block 1. Mapper 2, block 2. Mapper 3, block 3. Okay. Now, what is the output mapper 1 will generate, guys? Segregation. It has to segregate all the words.
Which have H in it.
Hadoop, not H. Okay.
Okay.
Hadoop.
Yeah.
Okay.
All words with Hadoop will be segregated.
Yes. Okay. So now, how many times a word Hadoop repeated in this example? In this?
One.
Huh? So first it will start reading. How to identify a word here? Tell me.
Word count.
How to identify a word? How will you say this is a word? What is a word?
Group of characters.
String.
Group of
Letters.
characters. A group of letters, okay, or characters, okay, separated by
Space.
space. That's also important, right? Okay. So here, okay. Hadoop and is okay. Here, how many words I have total, guys? I have 4 words. Okay.
Yes.
It will go through word by word. Okay. So what is the first word? Hadoop. Okay. It means so we need that word, right? So it will write okay. Hadoop 1 time repeated. Now it will read the second word is. Okay. Is it Hadoop?
No.
Okay. Now it will read third word. Good dot. Is it Hadoop? No. Okay. It will read 4th word. What is that 4th word? HAD. Okay. Is it Hadoop or only HAD?
HAD.
It is not Hadoop. It means okay. So mapper 1 output will say that okay, Hadoop repeated in this block. Hadoop repeated only 1 time. Yes or no?
Yes.
Okay.
Yes, sir.
So what mapper 2 will say?
1.
Okay, same processor for mapper 2 also. First it will take the first word OOP. Okay. It will check whether it is Hadoop or not. No. Okay. Then it will check with take is equal to Hadoop? No. Bad equal to Hadoop? No. Hadoop equal to Hadoop. Okay. So it will say Hadoop. time repeated in my place. Okay. Now, what is the mapper output?
0.
0. Okay. So here 0. It means no output.
Not
Sir, because okay, in this okay, there is no Hadoop word at all. Yes or no, no output at all. Correct? Okay. So now, okay, so let's say reducer started here. All the mappers are released. Okay, now reducer 1 has started. Reducer, what is the input?
count the number of H
Okay, so count the
in the
no,
words.
not hits or
Mapper.
Hadoops.
In the
Number of
mapper.
Hadoops.
Yeah.
Okay. For reducer, what is the input? Mapper 1
True.
output, mapper 2 output, and mapper 3 output. Okay. So now it will take a Hadoop. Okay, mapper 1 output it will take. Okay, this is the input. Okay. Mapper 2 output. This is the mapper 2 output. Mapper 3 output, no output. Okay. So it will take these 3 outputs. Okay. It will give you one final output. Consolidated output. Okay. What is the consolidated output? Hadoop. Yes or no? Huh? So now, after completion of this program, what reducer is saying? So in your file, in your sample2.txt, Hadoop repeated 2 times. Okay, is it a correct result or wrong result?
It's wrong result, sir.
It is wrong result.
Wrong
Right?
result. Yeah, it should be 3. Correct.
It should be 3, but okay. But here Hadoop is saying 2 only. But as per this correct only, na?
Yes, as per
Data
the
Hadoop repeated only once. In this piece of data, Hadoop repeated only once. In this piece of data, no
As per
Hadoop
one
word at
block,
all.
as per one block, one mapper theory, it is correct.
One block, one map per theory, it is correct. But okay, so if I go with one block, one map per theory, okay, suppose okay, if your data is like this will work out. Okay. If your data is like this,
It would.
if your data is like this, okay, your one block, one map per theory will work out. Correct or not?
yes.
Your data is like this, okay, your one mapper, one block, one mapper theory will work out. Okay, but okay, isn't it guaranteed that okay, words are not stored across blocks? So while cutting the data into pieces, okay, will it say whether it is full word or partial word, or okay, wherever it is 120 MB, it will cut.
Wherever 128 MB it will cut.
We don't
Exactly.
know when the word will cut.
So wherever it reaches 120 MB, it will cut there. Okay, so we cannot control data storing because okay, so it will cut based on the piece of 128 MB pieces. Yes or no? Yes or no, guys?
Yes.
Okay, so we cannot control we cannot tell Hadoop, okay, hey, so you're cutting at 128 MB, but okay, that is a full word. Okay, that is a partial word. So you put it here. Okay, so your Hadoop will never work like, okay, 128 MB first block, 130 MB second block, 140 MB third block. No. It should follow a standard of, okay, same blocks as across. Okay, across the same size across all the blocks. Okay, so definitely this is a common scenario in Hadoop. Okay, so in this scenario, can I use okay, one mapper per block concept?
No.
You cannot use. If you go in this model, okay, your output will be wrong. Okay, so what to do now? That is the reason. Okay, so now you tell me, guys. Okay, you tell me one thing. Okay, now here block 1, block 2, block 3. Okay, after completion of the job, is there any problem to this? Will they be deleted or they'll be still there?
Blocks will be there.
Blocks will be there, right? Okay, see, when these blocks will be deleted, when you delete sample2.txt. When you run a job, okay, nothing will happen on your data. You got my point?
Yes,
So now, Alan is running jobs on this data, SDFS, DFS, -ls, okay, project VLR, okay. He ran job on sample1.txt multiple times. Is it deleted? Huh?
No.
Is it deleted, guys? No. Okay, your input data is input data. That's it. Okay. So, but okay, without delete, it is not deleted. Nothing, no changes happen to this input. Okay, but still, okay, my output is correct only. Okay, my output is correct only. But okay, how Hadoop is managing that? Here, there is a concept here, guys. There is a concept. What is the concept here? Okay. Normally, okay, it is a common scenario in Hadoop that your words will be split across multiple blocks. It is a very, very common scenario. Understand? Understand? Are any questions? Okay. So your words, okay, are okay. Normally we call it a record actually. Your record will be split across multiple blocks. Okay. In this scenario, okay, so what Hadoop will do now? Okay. Hadoop will not blindly launch. Okay. Hadoop will not blindly launch on the blocks. Okay. So, and these blocks are on HDFS, yes or no? All these blocks are on HDFS. Will you agree with me?
Yes, sir.
Yes.
These blocks are HDFS. Okay. All these blocks are on HDFS. Okay. This is HDFS. HDFS means okay. Permanent storage or not? Huh?
Yes.
Permanent storage. Okay. HDFS means it's a permanent storage. Okay. All these blocks are available on HDFS, which is a permanent storage. Will you agree with me? Okay. So here, okay, what okay, Hadoop will do, Hadoop framework will do. Okay. Before starting this job, what it will do, okay, it will bring this entire data into RAM. Okay. Otherwise, okay, what it will do, it will convert these are the blocks. So now these are the physical blocks which are stored on HDFS permanent storage. Okay. But now what I'm doing, what Hadoop is doing, okay, if I process physical blocks as it is, there is a high chance that okay, you will get wrong output. Correct or not? That is the reason what Hadoop framework is doing. Hadoop framework is bringing this physical block into memory first. Memory and checking whether, okay, so it is bringing the first block into memory. Okay, so that memory is called as a split. Understood? Okay, in memory splits. What do you mean of in memory splits? It is bringing this block into memory first. Okay, this is memory. This is memory. When I say memory, what will happen? Once work is done, it will be
Released.
wiped out from memory. Okay.
Yeah.
So okay. So now it has got this first block into memory. Okay. It has got it. Now it will check whether the last one is a separator or not. Okay. When I say this is a full word. If the last character is space, then I can say it is full word. Sir, okay. Now, how will I identify a word? Word means, okay, see, it's a group of characters separated by a space normally. Correct or not? Group of characters separated by a space. Okay. So now here, okay, HAD is there. But okay, is it the last character is space in this piece of data? No. Okay. If it is not space, it means okay, there may be some extension. Okay, the extra characters may be there here. Yes or no? So what okay framework will do? It will bring this one. So it will check okay, last character is space or not. If not, it will go to the next block and get until the next space is available. So when it will get the next space? Huh? OOP space.
OOP space.
So here, okay, so I'm putting the underscore means okay, take it like a space. Okay. So till next space it will get here. Understood? Understood? Are any questions? Okay. So now this is okay. This is split one. Okay. Then okay, it is reading this one. Okay. But in this one, already OOP is given there, right? The remaining it
Yes.
will take. So no. Okay. But here it will check the last character is space or not. Last character is space. Last character is space. Okay. Now. Okay. Now. Okay. So Hadoop is good. Okay. So now, so this is 128 MB, 128 MB, 128 MB. Okay. But is it 128 MB? Huh?
No, sir.
This may
No,
be
sir.
150 MB, right? This may be 150 MB. Okay. After one, this is now after 150 MB. This is a small piece, right? Okay. Maybe
Less than 128.
less than 128. It means okay. Then it will take okay some more piece here. So at see each split it will make sure that it is at least minimum 128 MB. It will make sure. Okay. But now if you see 248, right? Okay. So 150 is used. Okay. This is only 98 MB. Okay. So if it is 98 MB, then what will happen? It will go and pick some more data from here. Okay. So here it will pick okay ease also. Okay. Hadoop ease also it will pick. Okay. Ease space it will pick. Okay. If you pick ease space also around okay 20 MB is coming. Okay. Still okay it is maybe okay. Still some more place is there. Okay. If I bring ease okay it is becoming 110 MB. Okay. But what is the minimum size of a split? 128 MB. Okay. Size, split size. Okay. So here block size equal to 128 MB. Yes or no? In the same way, split size also 128 MB. Okay. So now, okay, it will read till 128 MB. Then it will check. It will stop there. Check the last character is space or not. Is it space? No. That is the reason. Okay, it went here. And it has got this one also. So this split has become okay 150 MB. So split size is 128 MB. Okay. So here split size can be greater than or equal to 128 MB. Split size, okay, you don't have fixed numbers. It is purely based on your delimiter, your separator, word separator. Okay. Now, if you see this one, okay, if I add is also it is coming like 110. Okay. But if I add, okay, now if I add, okay, SU, okay, then it is becoming 128 MB. 128 MB. Okay. But now after becoming 128 MB, it is checking whether last character is space or not. Whether it should be space or end of the file. Is it a space?
Sir, last character no need to add into this block, right? Already space is there.
Where is the space, sir?
After Hadoop.
After Hadoop space is there, sir. But okay, when if I take only till Hadoop space, how much is coming now? It is coming like 98 MB. What is the minimum size of split here?
128.
100 MB. Okay, it means okay. So it means okay here. Okay, what it will do? It will go and bring the some other data from next block.
We need to maintain 128.
Minimum 128 MB. Sir, this work, okay, this split work will be taken care by us, or okay, it will be automatic process.
I think it's automatic.
Automatic process. We don't need to worry about this one. Okay. So now it is only going and checking. Okay, is it is bringing is. Okay. After bringing is and space. Okay. Space. Okay. It is becoming like okay 118 MB. Okay. 118 MB. But what is the size of okay split 128 MB, right? Minimum
128.
So now still there is some space. Okay. So now it will bring SU also. Okay. When it brings super, okay, then it has become 128 MB. Okay. But now it will check. After making it 128 MB, it will check now whether the last character is space or not. Is the last character is space?
No, sir.
No.
No. Okay. In this scenario, what it will do? So it will add PR dot also. Okay. But okay, after adding PR dot, it's a space. It is not a space, but it is the end of the file. That's the last character of the file. Yes or no?
Yes, sir.
Huh? Okay. So it means okay, this will become like 150 MB. Okay. Here, okay. So 300 MB file, which is of 3 physical blocks, have become two in-memory splits. Understood?
Sir, in memory splits and it's RAM lo store అవుతుంది sir.
RAM lo, sir. RAM. In memory, this is RAM. RAM. Temporary.
So So the physical blocks free అయిపోతాయి sir.
Physical blocks? Sir, physical blocks, they'll be there only. There is no problem to the physical block. They'll be always there only. Okay. Sir, okay. Why I am not directly running my, why I am not directly launching my mappers on physical blocks? Tell me.
Due to
If I launch,
Because they are already
irregular
blown.
outputs.
no. If I launch, okay, my mappers on each block, there are chances that I'll get wrong output.
Yeah.
Correct?
Yes.
That is the reason. First, what I'm doing, first, okay, I'm preparing my data. I'm not preparing my blocks. Okay, I'm taking a copy of these blocks and preparing my data like splits in the memory. Got it?
Okay. We need to maintain some RAM also for this.
No. This is an automatic processor. Don't worry. Okay. So now, okay, this work will be taken care by application master here. First, okay, application master will check. Okay, if this is my data, this is if these are okay. See, there is no need that okay, number of blocks equal number of physical blocks equal to number of in-memory splits. Got it?
Yes.
There is no rule here. Okay. So
Sir, but the purpose of memory itself is to do the processing, right? To get the.
Sir. Okay, see, let me tell you. Okay, it is not really bringing into RAM, sir. It is calculating where to cut. It means okay, now it is preparing split one. Okay, do one thing. Okay, so who is preparing splits here? These are the blocks. Okay, so what application master is doing? First, it is reading the first block. Okay, so it is creating split one. Okay, what should be the size of split one? Minimum 128 MB. Okay, yes or no? So no, split one.
Yes.
Split one. Okay. So what it will do first? Okay, it will bring the first block of. Okay. Okay. So it will bring here. Okay. Is it 128 MB? Yes. Please 128 MB. Okay. But now it will check. Okay, whether the last character is space or not. No, right? Okay. Then what it will do? It will go till next space is available. Okay. It means okay. So this is coming here. Okay. So now the split size, okay, so the rule is okay, split one should be greater than or equal to 120 MB. So now it has come like 150 MB. Okay. This is fine right now. Split one is done. But it is just calculating. It is not bringing memory, any data here. It is just calculating. So it is telling that okay, 1 to 150 MB is okay, 1 MB 2, okay, 150 MB comes under split one. Okay, split two. Okay, 151 MB. So it means okay. So again here is bad and Hadoop comes here. So 151 MB to.
Sir, one possibility in this case could be like while means 50 MB block is there in storage, but application master is splicing this based on 128 MB. This can be a possibility, yes.
Sir, very simple, sir. Whatever the physical blocks are there, okay, the physical blocks, okay. So now when I say okay 128 MB, okay, how it will be, sir? Physical block 0 MB to 128 MB, yes or no?
Yes, sir.
Okay, that means okay. See now, okay, you see here when my file is 300 MB file, okay, I'll not put 300 MB, sir. I'll put 299 MB. 299 MB file, okay. Okay, 296 MB I'll put. This is my file. Okay.
Okay, sir.
Here. Okay. So 0 MB to 128 MB will be in the first block, or not?
Yes.
What will be in the second block?
128 to 256.
128 MB to
256.
MB will be here.
Yes, sir.
Yes or no? Will you agree with me?
Yes, sir. Yes.
MB to
299. Yeah.
This is what the physical blocks. This is what physical block.
Yes, sir.
Correct or not? Okay.
Correct. Yes.
Okay, now I'm see what application master. Application master is converting this physical block into logical splits. What do you mean of logical split? In memory splits. So understand.
Got it, sir. Got it. Yes.
Is converting physical blocks into in-memory splits doesn't mean that it is bringing the data into memory. Understand? It is checking. It is continuously reading, sir. Continuously reading means, okay, does it mean that it is loading into memory? No, it is preparing a report now. Okay, saying that okay, so split one should be like this. Okay? Split two should be from split one. This is the one. Split one. Okay. Split
Okay,
one
sir.
will come like 1 MB to 0 MB to 150 MB. Okay. Split two will come like 151 MB to 296 MB. Okay. There are only two splits here. Understood?
Yeah. Yes, sir.
Okay. Understood, right? Okay. So now, okay, there are two splits. Now on top of splits, okay, it will launch one JVM. Understand? On top of splits, okay, it will launch a JVM. Now, okay, how many JVMs will be launched now? I have 3 blocks, but how many JVMs? Okay, how many containers will be launched?
2
Only
mappers.
2 mappers. Mapper 2. Okay, now tell me how many mapper 1 output? Hadoop. Okay. First word it will read Hadoop, it will write 1. Okay. Second word is not matching to Hadoop. Good, not matching to Hadoop. The last word is Hadoop, again matching with Hadoop. Okay. It means, okay, mapper 1 output is this one. Okay. What is mapper 2 output? Is not matching, bad, not matching. Hadoop, yes, matching. Okay. This is the mapper 2 output. Okay. So mapper 1 output is this one. Mapper 2 output is this one. Okay. So now let's say reducer 1 is started here. Reducer 1. Okay. For reducer 1, what is the input? What is the output it will generate? Now tell me, is the output correct or not?
Not correct. Yes.
Not
Yes,
correct.
No. Yeah. Correct, sir. Yes.
Correct, right? Sir, okay, here okay, try to understand, okay, it is not bringing entire data into memory. It is just, okay, counting from what number to what number will come to split 1, what number to what number come to split 2. Okay. When mapper 1 is launched, okay, what it will tell to mapper 1, hey, mapper 1, you need to process, okay, your input is 0 MB to, okay. So in this file, from sample2.txt file, your input is 0 MB to 150 MB is your input. Okay. So it will tell mapper 2, hey, mapper 2, you're in from this file, 150 MB to 296 MB is your input. You process 151 MB to 296 MB here. You process, okay, 0 MB to 150 MB. Okay. So you give me your output, you give me your output. Okay, finally I'll consult. Now I'll get to
Sir, in this in-memory split happens in HDFS itself.
Sorry, memory SDFS means storage, sir. Disk, sir.
Yes.
Okay. Sir, in memory, okay, see, I'm clearly saying, okay, 2 times I told, okay, 3rd time I'm telling, okay. So these splits are, okay, so just like a numbering, sir. It is not bringing actual data from here to here, okay. No actual data in the RAM, okay. It is preparing a report in the memory. This report is in the memory. Split
Okay.
1 from what MB to what MB will be split 1. From what MB to what MB split 2, okay. Will be decided by application master. Understood? So this report is in memory. Okay, don't think that, okay, this is complete thing is in memory.
Even what's fine and space also good also, it will take the memory.
Sorry, sir. Sorry?
Sorry.
So these 2 things are in memory, sir. Understood? Only numbers. Split 1 from what number to what number? Split to what? Again, this is a data or metadata?
Metadata.
Metadata. Okay.
Yes,
Understood?
sir, one doubt.
Your blocks are blocks only, sir. There is no change in the blocks before execution or after execution. Okay. But okay, if you process the block as it is, there is a problem because, okay, some words, okay, maybe splitted across, okay, across blocks. So here Hadoop is a word. Half of the word is here, half of Hadoop is here, half of the Hadoop is here. Correct. This is a problem. Okay, if you launch, okay, one container on one block, it is a problem. There are high chances that you will not get you will get wrong output. Okay. That is the reason, okay, what application master is doing. Okay, application master is okay, he started reading this file and understanding, is preparing a splits here. What is the concept for split? What is the rule for split? Split rules.
Greater than equal to.
Okay? Split size. Size. Okay. Should be
Greater than or equal to 128 MB.
Block
so
size.
should be block size. Okay. Should be okay.
Greater than or equal to.
Equal to 128 MB. Okay. Understand? Should be greater than or equal to 100 MB. Okay. Okay. And okay. If not end of the file. And if not end of file. Okay. Okay. So. Okay. Should be delimiter end of the file. Yes or no? Yes or no? Last character of the split should be either delimiter. Delimiter means field separator. Here, what is the separator? How the words are separated here? Space. In this example, it is space. It should be delimiter or end of the file. Understood? Understood? Or any questions? I will show you. I will show
Sir,
you.
what all delimiters will be allowed? Only space.
I'll tell you, sir. I'll tell you, madam. Okay. Okay. Let us take this scenario. Okay. So I have a table in RDBMS, sir. I have a table in RDBMS. Okay. This is the table. What is the table here? Understood? What is the table here? This is the table. What is the table here? I have employee ID, employee name, employee salary, employee department. This is the table I have. Okay. So what is this one? What is this one? It is one row or one record. Employee record, second record, third record, fourth record, like this. Okay, I have 10 records. Understood? Understood or any questions? This is the table, okay, I have in RDBMS case. Okay. Now, okay, I'm storing this table data into a CSV file. What do you mean of CSV file? Comma separated file. Okay. When I store all this data into a comma separated file, my data has come like this. Got it? My data has come like this: 1 comma Venkat comma 10,000 comma IT, 2 comma Raju comma, okay, 20,000 comma IT, Ravi comma 10,000 comma HR. Okay. So this is the CSV file I have. Okay. Now, what I want from this CSV file? This is the file employee.csv I stored into SDFS. Okay. I stored into SDFS. I think that I have 3 data nodes. Okay. Here, this is the data node 1, data node 2, data node 3. These are the 3 data nodes I have. Okay. Data node 1, data node 2, data node 3. Okay. Now I stored this file into SDFS. Stored this file into SDFS. Okay. This is the file stored into SDFS. When I stored my data into SDFS, okay, how many blocks it has come, right, guys? It's divided into total. What is the size of the file?
256.
Okay, it is divided into 2 blocks. Okay, one block is block 1. This is block 1. This is block 2. Okay. So block 1 will contain 0 MB to 128 MB. Okay. Block 2 contain 120 MB to 56 MB. Okay. So now, what is the data for block 1? This is the data for block 1 and this is the data for block 2. Understand, sir? Huh? So block 1 of, okay, the size is 128 MB. This is 128 MB. This is also 128 MB. So my full file size is, so here I have the file employee.csv. This is the file. Okay. This is the file I have. This file, this is the file. This is the file. Okay. Now I stored this file into HDFS. Okay, when I stored that file into HDFS, how would divide it? It divided into 2 blocks. Divided into 2 blocks, 128 MB, 128 MB. Okay. Good. So if you see, employee 1 full record is here in this block or not? Full record. When I say full record, what is full record? All 4 columns. Okay. Employee 2, all 4 columns are there. Employee 3, full columns are there. Employee 4 also all columns there. Employee 5 also all columns there. But employee 6. Okay. Here only first column, second column is there. Third column half. Okay. Half of the output is there. Half of the data is there. So, but if you see the second block, okay, in the first line, okay, you have 6th record, half of third column, half of the data, and 4th column is here. 7th record full is here, 8th record full is here, 9th record full, 10th record full. Okay, so this is how my data stored. Okay, now on top of this data, now I want to run a program. Okay, what I wanted to know, okay, what is my requirement here? I wanted to know sum of salary for IT and HR departments. This is what my requirement. Okay, so here there are some employees from IT, there are some from HR, there are some employees from finance. Okay, but I want to know how much total salary I'm paying for IT employees and how much total salary I'm paying for HR employees. Understand? Understand, or any questions?
Sir,
This is my requirement now. Okay, so normally if it is Oracle, okay, if it is a database, what you will write? Select employee department, sum of employee salary from employee.csv. Okay, from employee table. Okay, where employee department in IT, HR, and group by employee department. Okay, this is what the command you will run. This is what the command you will run. So this is the output. Okay, you will get. Okay, IT. Okay, so some number. Okay, HR, some number you will get. Yes or no? Yes or no, guys? Okay, so now here. Okay, so now in this example, okay, what is the key and value? We need to understand first. Normally, when anybody is writing MapReduce program, they should understand what is the key and what is the value. Okay, what is the key I'm expecting? I'm expecting department name is the key. For what departments I want to know salary? IT and HR departments. Okay, and what is the value here? Sum of salary I'm expecting paid by company. Okay, so this is my requirement. So now I need to write a program to get this output on top of this data. Okay, think that, okay, now this is the program you are writing. Okay, so there is a program. Okay, who will write the program? Client or developer or user should tell, okay, what to process here. Okay, so here while writing the program, we need to tell what is your input file, what is the location. Okay, so here what is the location here? The location of this file is, let's say, okay, so your location of the file is, this is the location of the file. You need to tell the input location, input data location or not in the command. Yes, right?
Yes.
Okay. And what is the logic file? Query.jar. This is the logic file. Okay. This query.jar will contain how many classes now? One main class plus main class plus mapper class plus user class plus config class. Understood? So it will contain total 4 classes: mapper class, reducer class, job config class. Total 4 classes. Okay. Now this is the okay. This is on edge node. Input is on where? Tell me. Input is on SDFS. Correct or not? But okay, where you have written where developer has written the logic file? He has written the logic file on edge node. This is the jar. This is the jar he has written on the edge node. Okay. What is the output location? Okay, you want to save your output?
SDFS.
Project BLR / out. Okay, under that output location. This is the location where I want to store my output. Okay. Now, input is comma separated file. Yes or no? What is comma separated file? Okay, your data is separated by comma. Okay. But okay, how are you expecting your output? How are you expecting? Okay, IT. So you are giving a tab some amount. HR tab amount. Okay, it means you are expecting tab separated file. Correct or not? Correct or not? Yes. Okay. So all this information should be provided. In your command. You should provide what is your input, what is your logic, and what is your output. Okay. These 3 things should be provided in your command. Okay. So here, okay, input, logic, and output. Okay, should be provided in your command. Yes or no? You see the command whether Alan is passing all this information or not. Alan has executed a job, right? Is he passing input file? Huh? Is he passing input file? Okay. Is he passing the logic file, jar file in the command? Yes. Okay. Is he passing the output location? Yes. Okay. It means these 3 are mandatory. Should be provided mandatorily in your command. In your yarn command. Understood, guys?
Sir,
These are the mandatory things. These are the mandatory things which you need to provide in the command, in your command. Here.
So the input file should be CSV format only.
Sorry, anything, sir. Anything. Hadoop can process CSV file, PSV, any format of the file. Okay. But in the current example, I am taking CSV file.
Okay. So when you are submitting job, no need to mention the file format, right?
You need to tell, right? Otherwise, how Hadoop will understand?
But in the example, you have not mentioned any file format.
Okay, that's what, sir. That's what. Okay, if you give me some time, okay, I'll explain. Okay, so these are the things which are mandatory in your yarn command. Okay, but now here, if you see here, okay, in the logic file, we have something called job config class. Yes or no? Yes or no, guys? There's something called job configuration class. Where? In this file. Okay, what you will give in this file? That is what I'm telling now. What you will give in this file? In this file, you are telling. Okay, in this file, you need to give all these things. Okay, all these things. Okay, first here, what is the record separator? How I will separate a record? How will I separate a record? So how? Okay, how will you say? Okay, this is record 1. This is record 2.
Separated by comma.
Separated by
Delimiter.
New line.
Separated by new line. Record 1 is in this line. New line. Yes or no? Yes or no, guys?
Yes, sir.
Okay?
Yes, sir. Yes,
So
sir.
in this example, okay, in this example, since I have taken CSV file, okay, you need to tell, okay, your comma, okay, your record separate is new line. Okay. But let's say my data is like this, sir. Now tell me, sir, what you will give?
Hash.
Have separated.
Hash separate.
Hash is the separator. Yes or no?
Yes,
So
sir.
this is my record. One Venkata 10,000 IT is the record. This record is separated by hash. Yes or no? Sir, okay, you asked me a question, right? Okay, so where to give the separator and all? Okay, so based on your data, you need to give the separator in the context XML file, in this file. Okay, if your separator is new line character, you should give new line character. If your separator is hash, you should give hash here. Understand? Huh? Understand, guys? Okay. Now, what is the field separator here? Okay. See, now this entire record is separated by new line. Okay. But okay, in one records, how fields are separated?
Comma.
Comma. Okay. But in this, okay, how fields are separated in one record?
$.
Okay. So now, so if you go in this example, you will give comma as a separator. Okay. But okay, if your data is like this, then okay, you will give a separator as $. Understood? So based on your data, you should give your row separator and column separator. Understand? So that's what I am telling. Okay. So can be customized. Customized means okay, you can give based on your input data. If your input data is a comma separated file, you can do comma separated file. Your input data is okay, pipe separated file, you can give pipe symbol. Okay. So what is the separator and all? Only the person who is writing the program will be knowing. Yes or no? Yes or no? Okay.
Yes,
So
sir.
this one. Okay. So now what is the column for key? What is the key column? What is key here? Key value. Okay. Key means okay, I want to know the sum of salaries for IT and HR. So key is IT or HR. Key is IT and HR. Okay. But okay, tomorrow if my requirement is okay, I want to have okay, IT and finance, then what will be my keys?
IT and finance.
Okay. But okay, tomorrow I want sum of salary for only IT. What will be my keys?
IT. IT.
Only IT. Yes or no? Okay. So it means okay, this also you should tell. Okay. This also there is no by default values. Okay, you should tell. Okay, user should mention this one. So here, okay. So user should mention. Understood? Okay. There is no default value for this also. Whoever is executing the program, okay, they should mention. Okay. This value, what is the column for key? Where, okay, in which column, okay, department name is available. Okay. Column for value, in which column salary details are available. Third column. Okay. So I'm telling the column number. Column for department name, column for salary name, salary. Okay. So these things, okay, I'm providing. Okay. Then output format. How you want your output format? See, your input format is this one, but okay, you can expect okay, your output in different format, right? So IT tab separated salary, HR tab separated salary. Like this, you can expect. Okay. So you can tell. Okay. So if you want, okay, if you want your output like this, okay. So IT hash. Okay, IT $. Okay. So some number hash. Okay. HR $, some number. Okay. Some number. Okay. If you want your output like this, okay, you want if you want your output like this, tell me how will you give? you will give, okay, in this place, okay, you in this configuration file, okay, you will give, okay, here dollar, and here give record separator is 5. But if you don't give anything, these are the default values it will take. Understand? Okay. See here, okay, wherever you see by default, it means, okay, if you don't provide, it will take this one. But here, okay, for these three things, okay, do you have any default values? No. Okay. So again, okay, column separator also, tab new line character. Okay, if you don't give, it will take this. Okay. Okay. Now JVM configuration. Okay. Normally, okay, what is the application master size by default?
1 core plus 2 GB RAM.
1 core 2 GB. How many application masters you will have? Only one application master in a job, right? Huh?
Yes, sir.
So by default is one. It is fixed. You cannot change it. You cannot tell, okay, I want 2 application master to complete this job. No. Only 1 application master per 1 job. Okay. And what is the split size?
Greater than or equal to 120.
Default is 128. Can I customize?
Yes.
Yes.
You want to customize, you can customize. Okay. Number of mapper JVMs. Okay. Size of mapper JVM size 1 GB 1 core. Okay. If you feel, okay, this is not sufficient, you tell what number you want. What is the size of mapper you want? If you feel this is not sufficient, you tell what is the application master size you want. Okay. Okay. Number of mappers. Number of mappers will be purely based on number of blocks or splits.
Number of splits.
Splits. Okay. Then okay, reduce the size. This is by default 1 core 1 GB. Okay. If you want, you can customize 1 GB 1 core. But if you want to customize, you can customize. Okay? But number of reducers. See, you cannot decide number of mappers. That is purely based on splits. But okay, can you define number of reducers?
Yes. Always 1.
By default 1. If you want, you can change it. Okay. See, all this information will be available in which class?
Job conf class.
Job configuration.
Okay, sir. Now tell me, okay, anything is missing. We are giving everything to job. Yes or no? You are passing this query jar means, okay, you are passing all the configuration also. Suppose if you feel that, okay, anything you missed in this one, you did not mention in this. One second. If I miss anything here, okay, those things I can mention in the command line like this. Understood? With -d, okay, you can mention. Understood? If anything, if see whatever is possible, okay, I'm giving here. Anything I missed here, okay, I can pass it in the command line. Okay, just 1 second. Class is not closed. 1 second. Okay. So this is what, okay, we are providing. Tell me what is not provided here. Everything is provided. Correct or not? Mapper size we are providing, reducer size, okay, application master size, okay, number of reducers, okay, then okay, column separator, field separator, okay, column key, okay, column for key, column for value, okay, output format, everything you are deciding here. Okay. So now here we have 2 blocks based on the delimiter, splits will be created. Then now see here, okay, when it comes to splits, how many splits are created now? 2 splits are created. Okay. So split 1. Okay. Now what happened? So based on these delimiters, what has done? Okay, it has brought this extra piece of data here from here. This is the blocks, right? This is the block 1, block 2. Okay, this has been converted into, see here. Okay, this extra piece has gone here, right? This extra piece has been brought back to this one, first split. Okay, now see here 0 to 128 MB, but okay, if this is split 0 to 150 MB is the split 1. Okay, split 2 is 151 to 256 MB. Understood? Okay. So now split 1 is 150 MB, split 2 is 106 MB. Correct or not? Huh? Now is there any problem now? Any half of the records are there? No half of the records and all. Okay. Everything is perfect. Okay. So now since we have two splits, okay, two mappers will be launched. Okay. So mapper 1 on split 1, mapper 2 on split 2. Okay. For mapper 1, what is the input data? Okay. Input 150 MB. Yes or no? For mapper 2? 106 MB. Okay. Output? Output. Okay. It will give you the output. Okay. So it will start reading, okay, each and every record. Okay. It will check. Okay. So I want, okay, data for IT and HR, right? So it will check whether IT, first record is IT. Yes. So it will bring IT 10,000. It will check second record, IT 20,000. Second record has come. HR, yes, we want this record also. HR 10,000. We want, okay, this also. HR, this one also. Okay. But okay, do you want, okay, finance record? No. That is the reason it is ignoring sixth record. Okay. This is the mapper 1 output. Okay. If you see the mapper 2 output, okay. So it is reading first record. Okay, it is a finance record. We don't want finance record. Leave it. This is also finance record. We don't want. Leave it. Okay. HR record, IT record. So it is bringing HR 10,000, IT 20,000. Okay. So this is the output of. This is the input of mapper 1. Output is this one. Understood? Sir, now.
Sir.
Ah.
Sir, one doubt, sir. So that
Yes,
means
sir.
the number of mappers will depends upon the number of splits, not number of blocks.
Yes, not number of blocks.
Oh, yes, sir. Because earlier we discussed, I mean, the number of mappers
Earlier
will...
I told like that, but
Okay.
now it is
Clear,
changed.
clear. Thank you.
Okay. So what is the output? Okay, mapper 1 output. Mapper 1 input is this one. Mapper 2 input is this one. Okay, mapper 1 output is this one. Mapper 2 output is this one. Okay. So now, okay, so here it will convert. Okay, now convert the output into key value. Okay, so now here, okay, I can see IT how many times? 3 ITs, 2 HRs. Okay, IT 10,000, 20,000, 20,000. This is a key value. This is key value pair of values. Key pair of values. Okay. So this is the okay. Now I have IT three numbers, HR 2 numbers. Here HR 1 number, IT 1 number. Okay. HR 1 number and IT 1 number. Okay. This is the partitioner. Okay. I'll talk about what is partitioner. So now, okay. Then sort and shuffle. Okay. Now by default, how many reducers we used, guys? By default, only one reducer, right? So if I use only one reducer, okay, then what will happen? Both IT and okay, HR will go to the same reducer. Okay. So it will start, reducer 1 will start counting IT. So for IT, okay, here 3 values are there. For IT, here 1 value is there. So it will bring all 4 values from both the outputs. Okay. This is the input here. For reducer, what is the input? Input is, okay, this is the one. HR. Okay. And here, this is the input, because okay, I have only one reducer. So this is the reducer and output with one reducer. Okay. So by default 1. Okay. So now output will be like, okay, IT, all ITs will be counted. If I count all ITs, I'll get 20,000. If I count all HRs, I'll get 30,000. Okay. So it means, okay, this is the output, okay, which will be written in a file and stored that file into SDFS. Now, if I open the output file on SDFS, you will get IT tab 70,000, HR tab 30,000. Understood? Understood, sir. Suppose, okay, if I use 2 reducers, what will happen? It's two reducers. Okay. What is reducer one input and what is reducer out? Okay, two input. Here, how many keys are there? This is the reducer one input. Okay. All ITs will go to one reducer. Okay. All HRs will go to one reducer. Understood, sir?
How reducer to it will take HR reports.
Okay. So here, okay, reducer two will decide. Okay, here this one will decide. Partitioner will decide. Okay. See, when we have only one reducer, there is no option. Okay. All IT records, HR records, both records should go to that one reducer. Correct? But if I have two reducers, okay, so reducer one will take all ITs, reducer two will take all HRs. So this will give, okay. So what is the output here? What is the reducer one output?
Is there any
Here,
possibility to take reducer one is take HR reducer?
So now, okay, I will have two output files on SDFS. Okay, first output file will contain IT 70,000. Second output file contains HR 30,000. Understood? Understood or not?
Yes, sir.
Okay, but if I use three reducers, sir, what will happen? If I use reducer 3 also.
No output in reducer 3.
Exactly. So for reducer 3, do you have any input? I have only two keys. One, okay, reducer 1 has taken IT, reducer 2 has taken HR. So for reducer 3, okay, no input. Yes or no? Okay, but okay, reducer 3 output, okay, output 3, yes, okay, empty output file it will create. Understood? Understood, sir.
So one question. Sir, one application master can take care of the multiple reducers, right, sir?
Yes.
For each reducer, there should be a different application master.
No. Sir, end of the day, see here, okay. Now you see here, for mappers, reducers and all, okay, same application master, right?
Sir, just I want to understand. I know, sir, but I want to understand on the for each and every job executed, one application master will be launched, right?
Yes. So okay, that one application master may control, okay, 1 lakh mappers or 1 lakh reducers also.
Okay, sir. Now, sir, how we can define the number of reducers? That how many reducers can go?
Okay, that's what, sir. Okay, how we define? Okay, we have some thumb rules.
Yes.
Okay. Yeah. Okay, we have some thumb rules. Okay, so based on that, you can define.
So what is partitioner here? We were discussing this.
I will talk about this partitions. Tomorrow class is this one. Okay.
And sir,
so
those rules also will come in next classes, sir. How the reducers will be defined, sir? Some rules.
How reducers will be defined? I'll explain the next class.
Okay.
Sir, quick question. When will Azure class start?
Sorry?
Azure.
Azure class will take some time, madam. Not immediately.
Yeah. Okay. So we can join that class. Will that be part of this Hadoop or?
Yes, okay, it will be part of Hadoop, but not in detail, in depth Azure actually. I'll give you like what is Azure, okay, how it works, and okay, how to create Hadoop clusters in Azure.
Okay, it will be 1 month course, no, sir?
No. Okay. Maybe I'll cover this Azure part, okay, around 3 to 4 days. That's it.
Okay.
Yeah.
Thanks.
Sir,